So first of all, we'll look at solving this with the substitution technique. The substitution technique you have to take one of your equations. I'm going to label this one equation 1, this one equation 2. You have to take one of your equations and get one of the variables by itself. In particular, I would look at this one. I think it's easiest to get y by itself. It would be really easy to rearrange equation number 2 by moving the y over so y is equal to 3x. Once you have that in, you take equation number 1, which was 2x plus 3y equals 11, and I'm going to put brackets where the y was, and I substitute in instead that y is equal to 3x. And what this does is it changes our equation to having two things that we don't know. Now we have a regular equation that we could solve. If I put my like terms together, 9x plus 2x, that's 11x equals 11, and x equals 1. Once you have x equals 1, you could plug it back into either equation. For example, it's really easy if I plug it back into equation 2, y is equal to 3 times x, that tells me y is equal to 3. And our solution is a point 1, 3. So on the graph, this is almost to scale, that looks like it could work. That they intersect at the point 1, 3. That's the substitution technique. If you can get one letter by itself, you substitute it into the other. The elimination technique, requires that you write all your x's in one column, all your y's in another column, and all your numbers in a third column. And then, in order to eliminate, you want one of the variables to be the same as the other, one of the coefficients of one of the variables to be the same as the other side, but one positive, one negative. So for example here, I'm going to rewrite equation number 1, which was 2x plus 3y equals 11, and equation number 2, I'm going to multiply it by 3. Because if I multiply equation number 2 by 3, I would get 9x minus 3y, and multiply 0 by 3 still would be 0. And you see here that I have in front of my y's the same coefficient, but one is positive, one is negative. What that allows us to do is add the equations together. 2x plus 9x, 11x. And then 3y and the minus 3y is going to be 0, and 11 plus 0 is 11. And we would get x equal to 1 that way as well. Now the reason I review systems of equations is because in the grade 11 course, it's assumed that you know that and can do that well if it comes up in the middle of a question. And it assumes that you can recognize it and do it if it comes up in the middle of a question. And judging by the overall reaction from the beginning of this review, that might not have happened. So we review our systems of equations. The key sort of, I like to think of this, if I have two things I don't know, I didn't know x, I didn't know y, and I have two equations, then I can use this technique. But if you don't have two equations, you can't do it. And so we go to example 3, which is one of the hardest examples, I think, in this unit because of this. And we want to find an equation of a quadratic function. So we have learned already that a quadratic function written in standard form, looks like this. And in order to write the quadratic equation, we need to find something for A, something for P, and something for Q. So there's three things that we don't know. But looking at the equation, can you see that they tell us one of them? Which number do you know, A, P, or Q, based on the information they've given? So read it, think about each of the things they've told you, what they mean, and then one of those things that they've told us, either the points or the axes of symmetry, tells us one of those letters. I'm not waiting, I just want you to think about it. I'm not waiting for someone to blurt out the answer or anything. If you think you figured it out, that's great. But if you can think of this on your own first, then your chances of remembering it when this question comes up later on a quiz or test are much better. So really think, what do each of those things do? What do they stand for? I'm still not going to tell you what the answer is, but sometimes taking the information and drawing a picture of what you know so far is helpful. What is an axis of symmetry? Well, the axis of symmetry is the vertical line where the parabola is symmetrical about. We know that this graph goes through 5, 0, and it also goes through -1, -6. Oh, that's a little bit off. Let's just drag this over. There we go. Yeah, just make mistakes, just move it around. You should try that on your paper. Okay. So this is what we have. Does that tell us anything? It actually tells us a couple of things. Okay? First of all, do you remember that P and Q make your vertex? Right? And your vertex, can you tell that your vertex has to be, this is so much good math. The diagram shows us so much. I know that my vertex has to be somewhere up here. How do I know the parabola doesn't go down like this? Because if it's symmetrical, this point would also have to be here on this side. And this point, which is 1, 2, 3, 4 away, 1, 2, 3, there'd be a point there on that side. And now, with those extra green points, I hope you can see that the vertex would have to be somewhere up on the top, and that our parabola is opening down. Now, if our vertex is up on the top, and I don't know where it is yet, I'll just do it in purple temporarily. Do you see that you know the x-coordinate of that vertex has to be 3? So we can go back and write it in words. And now we have this as the equation. So we've now got it down to 2 things we don't know. We don't know A, and we don't know Q. And if there's 2 things I don't know, how many equations do I need to make to be able to solve them? I need to make two equations to be able to solve them. So now this question is asking, is there a way to make two equations? Yes. They gave us 2 points. They gave us this point C and this point D. I can plug in point C, the -1 for x, and the -6 for y, and see what happens. So plugging in the -1 for x, so give me equation 1, and -6 for y. Can you see that -1 minus 3 is -4? -4 squared is positive 16. There's my equation 1. Equation number 2, I could plug in the other value. The other value says when x is 5, y is 0. So I plug in 0. Five minus 3 is 2. 2 squared is 4. So there's my simplified equation 2. I'm going to put a box around equation 1, a box around equation 2. We have now got back to that grade 10 question. We now have two equations with two things that we don't know. So we can either use substitution or elimination. And both would work, I think, really well in this situation. Okay? Can you see that you could easily get q by itself? If I take equation 2 here, and I move the 4a over to the other side, I get q by itself. I can now substitute into equation number 1. So equation number 1 was -6 equals 16a plus, but instead of q, I'm going to write -4a. Very important that if you get q by itself in equation 2, you don't plug it back into equation 2. Because then you will find some very interesting results like, oh, did you know that 0 was equal to 0? And then you're stuck. You're like, how does this help me? Because can you see if you plug this back in, you'd get 4a minus 4a. It would just go away and you'd be like, how do I solve for a? My a's went away, and I have 0 equals 0. You can't substitute back into the same equation you first got the letter by itself. You have to substitute into the other one. And when we do substitute into the other one here, divide both sides by 12. We get a is equal to -1/2. Once you have one of them, we can now find q. We knew that q was equal to -4a, so now I can plug in a, and -4 times -1/2 q is equal to +2. We're not done, because the question said find the equation. In order to find the equation, we needed to find the a value, the p value, and the q value. We found all three now, so now we can write the equation. Y is equal to a -1/2 x minus 3 squared plus 2. And if we look at this whole question, oh, it's quite long. Okay, we now know we can plug in a 2 here for the y coordinate of our vertex. Do things match up? Like, I'll draw my parabola here in orange. Wow. It went through that one. It's opening down. Does my a value match that? Yes. Right? When a is negative, it opens down. Okay? The half is a little hard to tell. Right? The half would make it wider because you'd go over 1, down a half, over 1, down 3 halves, over 1, down 5 halves. That's a little bit harder to see with just the scale. Like, is this wider than a regular x squared graph? hard to tell unless you drew an x squared graph on the same one to compare it. Okay, so this one is a little bit wider, it's opening down, and here is our final answer as a result. So, this I think is one of the toughest questions because it requires that you have a complete understanding of an entire unit of grade 10 that is normally not reviewed, right? I did the review of it because I've taught this long enough to know that if you don't do that review, then everybody's like, I don't remember that. Okay? The substitution method works really well here. Elimination would work as well, so you can choose whichever one you like the best, and then you can find everything. You don't always have to use a system of equation. Sometimes they give you hints in a question that it's like obvious what P is or what Q is, and you find two things quicker. Right? Sometimes you can use the shortcut. Like, for example, well, I'll give you an example similar, but I'm going to see if you can figure out a shortcut. Right? Let's say we're going to draw the graph. Again, they tell us the axis of symmetry. Let's say they tell us the axis of symmetry is at x equals -2. They tell us that there is one point at -1, comma, -1, and another point see if you like this shortcut. They tell us the other point is at 0, 2. Okay? So if you were doing this question, hey, x minus p squared plus q, it would be very similar as the one before. You would know because of these points and because of symmetry, you would also have a point here and 1, 2, 1, 2, a point there. So you know your parabola is going up. And we know that our p-value is -2, so we already know that you would have a +2 inside. Okay? How could you do a shortcut in this one? Well, see that you went over 1 up 3? So what would have to be there if it was doing the pattern? Over 1 up 1. That would be a shortcut in this one. And then I would know right away, oh, so my vertex is at -2, -2. And now I found out that my A value is 1 and my Q value is -2. So I'm done with very little work. Okay, so sometimes we can see shortcuts that get us our answer quicker, but other times we're going to need to do the system of equations. Both require different understandings. The shortcut means you really know the properties of parabolas well. And, right? As if I'm the teacher and I'm trying to get you to do a question of systems of equations, I'm kind of like, oh, they figured out a shortcut. I wanted to see if you could do the systems of equations, and you found the shortcut. Beautiful. But usually if you know the shortcut, it's probably you knew the systems of equation method too. So it's not a bad thing. Okay, so questions to practice here. Please circle question number 9.